and today we're going to cover isotope and calculating average atomic mass. Okay, so remember, isotopes, they're the same elements with the different mass. An example, these apples, courtesy of Miss Lemus, her great example. They're all apples, meaning they're the same thing, but however, if we put them on a scale, we're going to get different mass. Because one apple is smaller, another one is bigger. So they're all isotopes. On my assignment, I can give you an example of element carbon. And I have 4 isotopes of carbon. So let's calculate this really quick. I have carbon 11, atomic number of protons, which is 6. 6 is the same all the way across because it's the same element. Mass number, this is 11, this is 12, this is 13, and this is 14. So now my neutrons, 11 minus 6 is 5, 12 minus 6 is 6, 13 minus 6 is 7, and 14 minus 6 is 8. As you can see, same number of protons, 6, different number of neutrons, and different mass. So same element, different number, and isotope. Step 2, we're going to calculate average atomic mass. Because elements have different masses, we have to take all of it into account. Some of them are rare, some of them are more abundant. The example we're going to do today is 3 isotopes of magnesium occur in nature. Their abundance and masses are listed below. Use this information to determine the atomic weight of magnesium. In order to do this, we're going to follow 3 easy steps. Step 1, we're going to look at my percent abundance and move the decimal twice to the left in all of the percentages. Now, instead of 78.99, I have 0.7899, and so on. Step 2, I'm going to multiply my percent abundance by the mass of each element. Okay, I did the liberty of multiplying it to make it faster, so I'm just going to give you the answers. When you multiply these two, you get 18.9458. When you multiply 0.1000 times 24.98584, you get 2.4958, and when you multiply last two numbers, we are going to get 2.86068. Okay, after I have finished my multiplication, I have one step left. I am just going to add all my answers together. So I'm going to plug it in a calculator, and again I took the liberty of adding them to save time. My answer is 24.3051. Okay. The easy way to check this is my element is magnesium. So in order to see if I did the work right, we're just going to refer to the periodic table and find the atomic mass of magnesium. So let's go over here, magnesium, and guess what? 24.305. So we're very, very close, meaning we did the work right. The only thing I'm going to do over here is round my answer. We're going to round to 2 digits after the decimal. So I'm going to look at the 5 because it's a 5. The 0 is going to turn up by 1, and my final answer 24.31. The only thing I'm going to add is my unit, and look over here, masses are measured in AMU, atomic mass unit. So that's it for calculations. Look over here, example number 2 is for you. I did list the steps for you, so read the steps, follow what I did. Let me review. Move the decimal twice to the left in percent only. Multiply mass times percent abundance after decimal was moved. Add all answers and round the final answer to 2 digits after the decimal. And that's how you complete your calculation.